Okay, here we have another integral where we have to use partial fraction decomposition. Now, the first thing I want us to notice right here, it's a subtle difference in this problem. If you look closely, the degree in the numerator, the highest degree, 3, is higher than this degree in the denominator. So anytime we see this, and we haven't seen it before, we have to break this down first with long division. Okay, now this is something that's going to go back that we haven't seen in a while. Okay, but we have to go back to the algebra and use the long division. So we have 2x cubed plus x squared minus 7x plus 7. Now, if we remember, x squared will go into 2x cubed 2x times. 2x times x squared is 2x cubed. And then 2x times x is 2x squared. And then 2x times negative 2 is negative 4x. Okay, now once we sum this up, if you remember, this is positive, so it's going to be negative. This is positive, so it's going to be negative. This is negative, so it's going to be positive. 2x cubed minus 2x cubed, that's going to cancel. X squared minus 2x squared is negative x squared. Negative 7x plus 4x is negative 3x. And then, of course, we bring this 7 down. We repeat the process. X squared will go into negative x squared, negative 1 time. Negative 1 times x squared is negative x squared. Negative 1 times x is negative x. And negative 1 times negative 2 is positive 2. Once again, when we get ready to sum these up, we have to change the signs. Those are just the rules. Okay. Negative x squared plus x squared, that's going to cancel. And now, negative 3x plus x is going to give us negative 2x. And then 7 minus 2 is going to give us 5. So now, x squared will not go into negative 2x. All right, so this is our remainder. Is going to give us negative 2x plus 5 over x squared plus x minus 2. Okay, so now basically our new integral that we have to solve is 2x minus 1. Then don't forget we have that negative 2x plus 5. That's a plus over x squared plus x minus 2. Now, this 2x minus 1, that's going to integrate fairly easily. That's 2x squared over 2. Matter of fact, let's do it here. That's going to give us 2x squared over 2 minus x, which is x squared minus x. But now, we still need to find the antiderivative here. But what have we done? We've broken this problem down. That's why it's called partial fraction decomposition. We've broken this problem down to the point where now we can use partial fractions just to solve it. So let's go. We're definitely going to come back for here. We're coming back for that one. So we have negative 2x plus 5 over x squared plus x minus 2. Now I'm going to have to save room here, so I'm going to have to really start condensing. But this is going to be x minus 1 plus b and x plus 2. Remember, we have to factor this denominator. We have negative 2x plus 5 when we multiply by that common denominator, which is essentially this cross multiplication on this side, a times x plus 2 plus b times x plus 1. And now we have to create our 1's. So first, x is equal to 1, because in this problem, x minus 1, that would give us a 0. That's going to be negative 2 times 1 plus 5, which would give us 3. Remember, everywhere you see an x, you need to put a 1 there. That's going to cancel. So that's 3 is equal to 3a. And over on this side, we're going to have x is equal to negative 2. Okay. Negative 2 times 2 plus 5, that is 9. We put a negative 2 in everywhere. So that gives us a 9 and a negative 3b, which simplifies this. Oh, I didn't simplify it over here. 1 was equal to a on this left side, and negative 3 was equal to b. Now, y'all, I'm running out of room, but I have to create a little room. I hate to make this messy that we do this, but one thing now, we can bring back everything together. So what we end up having to do, what we have to do is, remember, that's 2x minus 1 plus 1 over x minus 1 minus 3 over x plus 2. Why? We took this problem, we put everything back in here, right? And now we simply find the antiderivative, which we've already found that. The antiderivative of 2x is going to be 2x squared over 2, which simplifies to x squared. The antiderivative of negative 1 is negative x. The antiderivative of 1 over x minus 1 gives us 1 natural log x minus 1. Remember, that's understood. And then this last term, negative 3 over x plus 2, that's going to give us negative 3 natural log of x plus 2 plus c. So remember, the degree of x was higher in the numerator. So we should start looking to start the decomposition by long division. Then we get our quotient, okay, which is 2x minus 1 and plus negative 2x plus 5 over x squared plus x minus 2. Okay, we see that the 2x minus 1 is going to, we're going to be able to integrate that fairly easily. But the negative 2x plus 5 over x squared plus x minus 2, we still have to break that down with partial fractions. We go through using partial fractions. We solve for a and b. And in the end, where we put in this square right here that we created, I was running out of space. We put everything back together, our quotient and our partial fractions. And like we said, the final answer after we integrated was